Hi to everyone. MEM School of Engineering, Department of Mechatronics Engineering, online classes, subject analog devices and circuit. Unit number 1, analog electronics. This is the last chapter of unit number 1. So in this chapter, we are going to discuss about the oscillators. That is, we are going to generate the signals without input. So amplifier with the positive feedback acts as a oscillator. So this is the basic definition. You'll see the amplifier with the positive feedback act as a oscillator. That is, it will be produce the more signals. The transfer function of the feedback amplifier is follows: AF is equal to A divided by 1 minus A beta, where A is the amplifier gain, beta is the feedback factor. Okay, so AF is equal to infinity, which condition for oscillations. So principle for oscillation. So when it is um, when it is oscillator means it is having some definition. One is damped oscillation, another one is undamped oscillations. The electrical oscillations in which amplitude decrease with the time are known as damped. So that is like this. That is initially it will be high, but in the output it will be low. That is damped. So undamped means the electrical oscillation which amplitude does not change with the time. Does not change with the time, known as undamped oscillations. Okay. Here, the amplitude of the oscillators are constant with the time, and there is no change in the frequency. Okay, the undamped oscillations are produced by the providing the energy compensation circuits. That is, frequency is equal to oscillation for the frequency will be Fs equal to 1 divided by 2 by root of Lc. Okay, so that is a LC called the tank circuit. Okay, so let's see the one by one. So basic types of oscillators, that is, one is sinusoidal oscillator and another is non-sinusoidal oscillator. So sinusoidal means it will be produce sine waveforms. So non-sinusoidal means it will produce a triangular, square, then sawtooth, like that. It is called a non-sinusoidal oscillators. Okay. So sinusoidal oscillator, the static electronic device that produce the sinusoidal oscillations of desired frequency is called sinusoidal oscillator. Examples of LC oscillator and RC phase shift oscillator. Okay. So already we discussed these parts. Then see the amplifier circuit only. RC oscillators. These oscillators employ resistors and capacitor. There are more suitable generating frequency signal. They are also known as AF, audio frequency oscillator. These have good frequency stability. So types of RC oscillator, that is Wien bridge oscillator and RC phase shift oscillator. These both two defines the output as a sine waveform. Wien bridge oscillator. This is a basic amplifier circuit which is having the Wien bridge model. So here we have a 180-degree phase shift, so it will produce the output. This is the operation of oscillator, that is F is equal to 1 divided by 2 pi root of R1 C1 C2 R2. That is the output frequency with respect to the R1 C R resistor and the capacitors. If you are fixing R value as the same, so output will be F is equal to 1 divided by 2 pi root of RC. Sorry, RC. So the desired frequency of oscillations can be produced by varying the two capacitors C1 and C2 simultaneously. These oscillations are fed to the first transistor 1. So after amplification, these amplifications are fed to the second transistor T2. So this is the working of Wien bridge oscillator. So advantage, That is, output is constant. It is working is quite simple and easy. Overall gain is high. It has far better stability. Frequency of oscillation can be easily adjusted. Disadvantage cannot be used to generate very high frequency. Costly as more components are used. So next one is Hartley oscillator. This oscillator is very popular. That is used in the local oscillator in radio receiver. It uses inductive oscillator. That is here they are using the two inductors and one capacitor for this oscillation. Okay, that is Hartley oscillator. That is two inductor and one capacitor. That is output frequency follows the condition of L and C. That is F is equal to 1 divided by 2 pi root of L1 plus L2 into C. Okay, if both the L are same means that is 1 divided by 2 pi L root of C. So like that we can take as the Hartley oscillator. That is this produce the 180-degree phase shift by the transistor circuit as well as 180-degree phase shift in the tank circuit. Okay. So advantage easy to tune, adaptability to wide range of frequency, used as a local oscillator in radio receivers. Disadvantage means harmonics rich content of the output. It is not suitable for pure sine wave. Next one is Colpit oscillator. This is the opposite of Hartley oscillator, which is having Colpit means it is having two capacitors and one inductor. Colpit having two capacitor and one inductor for in the tank circuit. So that is when power is on, the collector current starts rising and charges the capacitors C1 and C2. When these capacitors are fully charged, it is discharged through the coil L1, setting up oscillation. This oscillation process repeatedly given to the process. So the transistor will give 180-degree and the 180-degree phase shift done by the tank circuit. So the frequency of oscillation is given by F is equal to 1 divided by 2 pi root of L CT. That is CT is a combination of transistor because both CT means combination of capacitor. So capacitor are connected in the series. So CT is equal to C1 C2 divided by C1 plus C2. Okay, this is the concept. So that is sustained oscillation for better oscillation, that is Basian Criterion. Condition 1 will be beta is equal to C1 divided by C2. Condition 2 will be the phase feedback is correct. The tank circuit of L C1 are 180-degree out of phase. The further 180-degree phase shift done by the transistor. Okay. Thank you.